Hello everyone, welcome to Physmatica. Before we start the problem, please forgive me if there is a sound of the seagulls. I cannot get rid of them today. They're like literally everywhere. But anyway, the problem says, in the xy plane, what is the shortest path from 0, 0 to 12, 16 that does not go inside the given circle? What do we mean by this? Imagine this. Imagine that I have a coordinate system. And then there is a circle here in this coordinate system like this. And there are 2 points. One of them is here because it's 0, 0. I'm going to call this A. There is another point. For example, here, I'm going to call this D. And the whole point is, what is the shortest path from A to D that does not cut the circle? So it can be tangent to the circle, but cannot go through the circle. First of all, given this equation of the circle we have here, what is the circle is going to look like? So what is the radius of it and what is the location of it? It's very simple. We can clearly see that based on the equation of the circle, if this is A and this is B and this is R, we can clearly see that O as the center of the circle is going to be 6 and 8, and my radius is going to be 5. So this circle that we have has the location of 6 and 8 for the center and the radius R. So if I say this is my O, then this is my radius R, which is 5, and this is going to be 6 and 8. So this is going to be 6 and this is going to be 8. Okay, we have this now. But the whole problem comes to this point right now. Which direction should I take? What's the shortest path? Does it matter if I go like this or if I go like this? Does this matter really? So first, we need to find a way to solve this direction problem. So I'm gonna call this direction. There are multiple ways you can do this. I found out that this might be the easiest way. The easiest way is this. Let's say I want to find the equation for this line AD. So I have this line AD, but what is the lines AD's equation? So it's a straight line, so it's going to be mx plus b. B is going to be 0, simply, so it's just going to be mx. We need to find the slope. M is going to be y2 minus y1 over x2 minus x1, and we have this y2 minus y1 and x2 minus x1 here. So this is A, this is D. Simply said, it's going to be 16 over 12 because A is 0. So it's going to be 4 over 3. So the equation is like this. This is the equation of this line AD. Now I'm going to do this. I'm going to say what happens if I say x is 6. This 6 is coming from this, from the center of the circle. We can clearly see that y is going to be 8. And this is important. Why? Because it's telling us that this line AD is cutting this circle in half, and it is actually passing through the center. So because of this fact, we can just simply say that we have symmetry here. So it doesn't matter which direction we take. It doesn't matter if we go from left or right, it's gonna be the same. And this is much easier now to solve. Everything is much simpler. We will have a lot of symmetries and similarities here that we can use. So now, as the second step, let's just solve the problem. So I'm gonna say this L is what problems want. It's the shortest path. And this is my assumption. I'm starting from A and go tangent to the circle right there. I'm gonna call these points of tangency B. Then I'm traversing a bit on this circle on the arc. And then from there is another tangent point to the circle that I'm just moving from there to D, and I'm gonna call this C. So what problems wants from me is lengths of AB plus this arc BC plus this length CD. So this is what problem wants from me, and I need to solve this. It's very simple, especially for these circles, it's quite simple. All you need to know is just one fact. The fact is, when you have a straight line that is tangent to a circle, that straight line and the radius of the circle are perpendicular in that point. What that means is this. If I come down from here and if I come down from here, these are the points that are tangents. These are making right angle right now. So that's the whole thing you need to know to solve this problem. So having this, we want this and we want this, but we know this is 5. So how we can solve this? This is a right angle. All we need to do is to find the lengths of RO or OD, doesn't matter. So the whole point here is because we established that the triangle ROB is the similar to the triangle DOC, then it doesn't matter which one we take. So we can just ignore one, do whatever we want and solve everything for this triangle right here, and it's going to be exactly the same for triangle DOC. And this is because of that symmetry that we talked about. So now let's see what happens. I'm just going to bring this here so it's more clear. So I'm going to say that how can we find this? This is now our x. If I draw this triangle, right triangle, sorry about that, that was an awful triangle. So if I draw this triangle, this one is even worse. But anyway, so I'm going to say that this is A, this is B, this B is right here, which is the right angle, and this is the center of the circle that I have, right? So we know that OB is 5, right? And we know we want to find this, and this is the problem that we want to find. So this is for the problem itself, but we need this to solve that. Okay, this is just a right triangle with a hypotenuse. How we can solve that? It's quite simple now. We already have this as 6, and we already have this as 8. So this x is just the hypotenuse of this triangle, because this is also a right triangle. So I can say RO equals square root of 64 plus 36, 8 to the power of 2, 6 to the power of 2, which is going to be the 100, so it's going to be 10 units. So from here I can just say that this x right here is 10. So this is 10, this is 10, which 5 of it is inside the circle and 5 of it is just this outside, doesn't matter. So how can we find RB now? The length of RB is just simply going to be, so we have this as 10 right now, it's just going to be 100 minus 25. Again, this is a right triangle. Now we are solving for this. We have the hypotenuse, we have one of the lengths. All we have to do is to just solve the Pythagorean theory for that. Is going to be a square root of 75, which is going to be 5 square root of 3. That's it. We solved it. So we have this 5 square root of 3. And we also mentioned these two are exactly the same. So these are going to be the same length. So we can just say CD is also 5 square root of 3. 5 square root of 3. So what we want right now is just one simple thing. What is this arc? We just need this arc and that's it. So let's find the arc. How can we find that arc? I'm going to write the circle here. This is the circle that we are working on. This is O. This is point C, tangent point. This is tangent point B. This is the arc that I walked in. I need the theta because we also have R as 5. I need theta to find the arc lengths. First of all, the length of an arc, again, multiple ways you can solve this, but the length of an arc, the simplest formula is this, 2 pi r theta over 360. We have r, we have everything, all we need is theta. So how we can find theta? Again, we can use many ways that we could find it. First of all, let's find this. Let's say that this is theta that we're looking for, but to find that, if we find these two angles, or even one of them, we can find theta. So let's do that. I'm going to call this beta, and I'm going to call this alpha, right? Now we could just use the law of sines. Again, there are multiple ways you can do this. You can actually use the similarities of the triangles to solve this using the triangles and the circle, but the best way, simplest way, and a general way is to use the law of sines, because we have a triangle that we know all the lengths of it, and we also know one angle, so we can find the other two angles. What I mean is this. Let's just write it like this. I'm going again to say that this is the triangle that I'm looking at. I have A from here. I have O as the center and I have B, right? This is 90 degree. This is alpha. This is beta. I had this as 10. I had this as 5 because this is the radius. Then I found out that this is 5 square root of 3. So how can we find one of these angles? Let's just start by finding this one because it's simpler. We don't need to deal with 5 square root of 3. So I'm going to say that with another color right here. I'm going to say, for example, A sine alpha equals B sine beta, which by beta, I shouldn't say actually beta, let's just say 90 degree here. The reason is this. I'm saying that this length here for this angle and this length here, which is 10, for this angle that we know. So it's going to be 5 over sine alpha equals 10 over sine 90, which is going to be 1. So from here I can say sine alpha equals 1 over 2, and from here it's just the arc sine. We can simply say alpha equals 30 degree. That's it. We found it. So if our alpha is 30 degree, then this beta is going to be 60 because this is going to be inside the triangle itself. So having that, now we found out this is 60. So this angle right here is 60. What is going to be the theta? So again, if I just write it simply here, so you could see it better, we found out that this is 60, this is 60, so theta is gonna be 60 as well. That's it. So the problem is solved now. Let's just go and substitute everything. I already said that to find the length of an arc, we can use this. Now we have everything. So we have 2 pi multiplied by 5, which is the radius. Then we found the degree, the angle is 60 degree. Then we have 360, which this one is going to simplify with each other. This is going to be 6, and this is going to be simplified again, going to be 3. So it's going to be 5 over 3 pi. And that's the length of that arc. So now let's put everything together. This is going to be length of an arc, which was, how much was it? 5 over 3 pi. 5 over 3 pi. Okay, so now let's see what we have. Length, the shortest path is going to be 2 5 square root of 3, so it's going to be 10 square root of 3 plus 5 over 3 pi, and that's the solution for this problem. It's a very simple problem but has some points in it, and it's actually a very interesting question overall because of this fact that now I'm going to ask you this question. We already established that if we have this symmetry here from point A to point D, it doesn't matter which direction we take because this line AD was passing through the circle. But what if I ask you this? What if I say we have point A and we have point D', and this point D' does not go through the center. So the line equation right here, this doesn't pass through the center of the circle. So what is the shortest path now? Because now it does matter which direction you take. If you go from here, this path actually is longer than this one. So it does matter. And this is a very interesting problem. Think about it. See if you can find a general form. So this is going to be the general form of this problem. What we just solved was a special case. See if you can solve it. Please leave a comment if you want me to solve a problem like this as well for the general form. And thank you for watching.